what I want to do in this video is to show you how to make a template for doing confidence intervals with population proportions. And so I'm going to make a number of sheets. I'm going to call this first sheet a template. And what I'm going to do on this sheet is I'm going to create a generic Excel file that I can modify from problem to problem, and it'll automatically compute the confidence interval for me. So let's see what it is that we need to compute a confidence interval for population proportion. So I'm going to go ahead and scroll down here to chapter 10. And if we recall what the formula for confidence interval is, it's the margin of error, it's the point estimate, which will here be our sample proportion, plus or minus the margin of error. Right, so this is our general formula right here. So what I need is the sample proportion from either a data set or it's given to me in the problem, and then I need to compute the margin of error. So the real problem when we're doing a confidence interval is we have to compute the margin of error. And we might want to start off actually making two templates. So this is a template where we have summarized data. In other words, we're given the pi hat. Okay. And we could create another template for when we have to get these values from the data. So this is when we're given a raw data set. We're not given pi hat. And so for each of these, we need pi hat. That's our estimate. But we're going to need a little bit more from the raw data, right? So we're going to need the number of successes or the number of people in the category we're looking at. We're going to have to get that using a COUNTIF command, and then we're going to have to use the sample size, and then we'll be able to compute pi hat once we have that. So this part of the data set deals with the estimator. So I'm going to go ahead, I'm going to color that a little differently. All right. Now let's see how we're going to compute the margin of error. So in other words, when we're given the sample percentage, we just enter its value, right? When we're not given it, we're going to have to compute it from an actual data set. Okay. And just go ahead and put a little border on these guys too, just really quick while we're doing all this. All right. Okay, so let's go ahead and take a look at our class notes and see how we're going to compute the margin of error for a population proportions confidence interval. So if we scroll down here, we see that this is the formula. So the formula says we're going to compute the z-score, which is going to tell us how many standard deviations wide to make the margin of error, and we're going to do that using the confidence level, okay? And then we're going to go ahead and we're going to compute it by the standard deviation of the estimator. And this is the estimated standard deviation because we don't know the actual population proportion. We're working with the sample proportion. So let's kind of break these down. Let's compute the z-score first. Let's compute the estimated standard deviation of the estimator, and then we'll multiply them and get the margin of error. And so I can kind of split my screen a little bit here. And we'll try to see how this works out. Of course, this calculation will be the same for both summarized and raw data sets. So I can simply copy and paste for the summarized data set onto the calculations that we're using for the raw data set. I'm going to go ahead and kind of bring this down a little bit. Okay, so let's go ahead. This will be the calculation for the margin of error. So let's go ahead. We need our confidence level. Again, that's going to be given. And then we're going to compute our z-score. We're going to call that z star. And the same thing for the raw data. See, it's the exact same thing that we're computing. Okay. Once we have our z-score, we need our margin of error. We need our estimated standard deviation. So I'm going to go ahead. I'm going to put n here since this is going to be given information. And then we'll say standard deviation of pi hat. Okay. And we'll just do the same thing here. And then all we're going to do is we're just going to multiply them. So the margin of error will just be their product. And then we can compute the upper confidence interval limit. In other words, this is just the upper level, this is just the upper confidence interval endpoint. Let me just write it that way. Sometimes people call it level. I'm going to call it endpoint. And this is going to be the lower endpoint for the confidence interval. And again, we're going to do the same for both of these, okay? And actually, just to make this simpler, why don't I do this? I'm just going to make one chart. This will make life a little easier. This is a summarized data set. This is a raw data set. And I'm going to have a number of successes here. And I'm only going to need that for the raw data set. And that way I don't have to do this whole thing twice. I only have to do it one time. Okay. So summarized raw. And of course, I'll put the raw in red so we know which ones are specific to the raw. Okay. So this is specifically for the raw data set. Okay, so this will be the information that we need to compute the z-score for the standard deviation. That's okay. And then the margin of error. So the margin of error is just equal to our z-score times standard deviation. And so what I'm going to do is I'm going to go ahead and I'm going to use some of the problems in the book. So let's look at example 1 on page 205 first. Whoops, I already had it up. Okay, so on page 205, this is our problem. So this is an actual survey that's done by some major universities of Middle Eastern countries. It's called the Arab Barometer. It's done every 4 years or so. And so in this particular question, we're looking at the respondents from the country of Algeria. And we're told that 1,999 Algerians were asked the question, do you have a mobile phone or smartphone with interconnection? To which 1,181 responded yes. And what we want to do is we want to compute the 90% confidence interval for the percentage of all Algerians who either have a mobile phone or a smartphone with internet connection. Okay, so first of all, we want to understand the study design. We want to understand what is the variable, what is the population, what is the parameter. Well, our population is all people in Algeria, or you might say all people in Algeria who could possibly have a smartphone or a mobile phone. Our variable is the percentage of people in that population. that have a mobile or a smartphone. And so our our variable is whether or not it's the response to the question, whether or not they have a mobile or smartphone. The parameter is the percentage of people in that population that have a mobile phone or a smartphone. We want to look at our data collection. Okay, we're going to assume, since it's done by a major university, they did a good job. They took a random sample. And in fact, if you read the survey methodology on the website for the error barometer, you'll see that they do an incredibly good job. It's certainly large enough, right? We need 10 people in each category. So we have roughly 2,000 people. 1,181 are in one of the categories, yes. So this means that there's going to be, 19 people in the no category, so we're okay. The exploratory data analysis, okay, we could go ahead and make a plot with the data. I'm not going to do that, but we definitely want the sample percentage, right? So now we're ready to start putting stuff in here. So we have summarized data. Number of successes here was 1,181. Our sample size was 1,999. Sometimes we're given the sample percentage, sometimes we aren't. Here we're not. We're given the summarized data, but we're not given the sample percentage. So I'm going to have to go ahead and compute that. And so roughly, we have about 60% of the population. Okay, and by the way, the number of no's in the category, I apologize, I said 19, sorry. It's actually 819, right? Because it's 1999 minus 1,181. Sorry about that, 819. So again, our conclusion for the data collection doesn't change. We definitely have 10 in each category, just in case that was throwing you off. Okay, statistical model, we know that it's going to be a normal distribution. It's centered about whatever the population parameter is, which we don't know. And now we're going to estimate the standard deviation of the distribution of the sample estimates. So we're looking basically at the sampling distribution. So remember what this formula was. So this is going to be equal to the square root of, we got to be a little careful. So it's the sample proportion times 1 minus the sample proportion divided by the sample size. Oops. Okay. We have to be careful with the parentheses here, okay? We have 2 left parentheses, we have 2 right parentheses. We should be okay. But if we got something wrong, we'd have to go back and probably look at the formula, right? And we see that that's the standard deviation. If we took a really, really large number of samples, random samples of this size, and we looked at the sample percentages, this would be their standard deviation. Okay, our confidence level here is 90%. We always express the percentage as a decimal. We're doing math with it. Our z-score, we're going to have to use the norm inverse formula, right? Here we're given a percentage, and we want to find the z-score for it. So we're going to use norm.inv. And I'm going to use norm.s.inv because I'm working with the standard normal. So here, remember, we're going to do 1 plus the confidence divided by 2. So I'm going to be a little careful here. 1 plus this value divided by 2. If you wanted to, you could take 1 minus this and divide it by 2, but then what's going to happen is your z-score is going to be negative, so you're going to have to correct for it. So this makes it a little bit simpler for us. All right. Now we're ready for the margin of error. All I'm going to do is I'm going to just multiply this by this. There's my margin of error. So it roughly tells me that the margin of error is about 2%. And remember what we said before. If you want a 2% margin of error, you usually need about a couple of thousand of people, and that's what we have. We have roughly 2,000 people here. Okay, what is our upper endpoint? Well, I'm going to take my sample estimate, and I'm going to add the margin of error. And here, I'm going to take my sample estimate, and I'm going to subtract the margin of error. This value has to be greater than this value. If it isn't, we probably did something wrong. I'm going to convert them both to percentages, okay? Just for the sake of simplicity. I want to do format, if I can get there, and convert this to percentage. And I probably don't need any decimal places. That's okay. And so this tells us between 57 to 61%. We're 90% confident that between 57 to 61% of the people in Algeria have either a mobile phone or a smartphone with an internet connection. Okay, and again, for this data, for this particular raw data set, I'm going to have to use COUNTIF here, right? But I can go ahead and I can bring this over. I'm not going to do it because right now I'd end up getting a weird number since there's 0 here. But essentially, once you fill this in, you can use the same commands. Once you fill this part in, you can just do the confidence, bring this right over, 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 and you'll be totally done. Okay, great. Let's do one other problem. I want to do example 4 from page 212. It's a sample size calculation. So this is computing the confidence interval. I'm going to do a sample size calculation here. And if we go back and we look at the sample size calculation formula, here I can kind of blow this up a little bit. All right. So the sample size calculation, let's go ahead and look at that. Where is that in the notes? So here's our sample size calculation. It says basically that we're going to take the z-score, which we're going to get from the confidence level, multiply it by 50%, divide it by the margin of error. Okay, again, expressed in terms of percents, okay? So again, what are we going to need? Well, to get the z-score, we need the confidence level, and we need the margin of error, right? So confidence level, then we're going to compute the z-score, we're going to enter the margin of error, and then we're going to go ahead and compute it. Okay, so in problem 4, we're going to look at the confidence interval for the percentage of rats that were empathetic. Change that real quick. So here, we want to ask how big. So one of the problems with that rat empathy study was we saw that the population proportion actually was in a really wide confidence interval, right? Our confidence interval was really large because we had a very, very small sample size. And in fact, it was so small, we couldn't even actually compute the confidence interval, if you remember back in the notes. So we want to say, suppose they wanted to get a confidence interval for the percentage of rats that would open the door that had a margin of error of 5%. And we want a 95% confidence interval with a margin of error of 5%. How large of a sample size would they need? Okay, so let's see how to do that. So here, we're going to say that our confidence level we're going to enter here, and that's going to give us our z-score. And then we're going to go ahead and enter the margin of error that's given. And then finally, we're going to compute our sample size. So the confidence level in this problem was 95%. Again, we're going to compute the z-score from the standard normal distribution. And I'm going to use exactly the same formula. In fact, I could have copied and pasted what I did for the confidence level calculation a second ago, but we'll compute it again just because it's good practice to know how to do this correctly. Okay. And we see for a 95% confidence interval, z-score is about 2, and we know that that's right. Our margin of error expressed in percentage is 5%. So our sample size is equal to 50% times our z-score divided by our margin of error, the whole thing squared. Okay? So it's roughly saying 50% times 1.96 divided by 5%. And so we need at least that large of a sample. And of course, we'd round that off. That would be 385. Okay. So that's how we do our sample size calculation. Now, I'll show you a little cool trick that people use sometimes. Notice that this is about 2. So you can actually estimate so for a 95% confidence interval, n is roughly about, well, notice 50% times, this is about 2. So it's roughly 100% divided by the margin of error squared. That's actually a pretty decent estimate. Okay. Again, I'd rather you do it exactly, but you can see that if we actually did this calculation just really quickly, 100% divided by the margin of error squared, I'm going to get 20 squared, which is 400. Okay, so I'm going to get something pretty much in the ballpark. So this is kind of a nice, easy way to actually check your work. Okay, that's all there is pretty much for doing confidence intervals with population proportions and sample size calculations. And so what I would do is I would go ahead and I would actually save this, and that way when you're on an exam, all you have to do is copy and paste. When you copy and paste, remember to paste it with formulas. If you don't, you're going to lose all these nice formulas and have to re-enter them. But on an exam, on a quiz, on a homework, whatever, it'll save you a lot of time.